So for starting, our purpose is to provide evidence that the connection between enterprises in terms, in this case, of shared decision makers can influence ESG scores. So some of the research questions that arose are: how do shared decision makers influence the company performance and, of course, the ESG performance? That is something that we're going to explain later. And while doing the methodology, also this was an interesting question, because is it possible, or can leveraging this network structure enhance the accuracy of, in this case, ESG performance prediction? So in order to understand this purpose and, of course, the question, we're going to speak a little bit about the context, because we know that nowadays many companies face different or several impacts by external factors. For example, a shock of raw materials, the inflation, some geopolitical instability, and this is something that may affect the strategies and the investments that decision makers want to take into consideration. So it's interesting to analyze how this network of enterprises can influence each other in terms of strategy and towards, in this case, green's objectives, sustainability objectives. And we have to mention that the public demand for sustainable strategies on environment, social, or different impacts is increasing. So what is ESG? What does stand for? In this case, we can say that it's a set of practices. In this case, we can say investment decision strategies that companies or organizations implement to limit negative impact or enhance a positive impact. In which pillars? Environment, society, and governance bodies. In this case, if we speak about a company, we can say the mission of some gases, the reduction of emission, the saving some energy in some, let's say, production companies. When it comes to the social, it's about, for example, the company's human resources, if there is a quality standard and so on, and the governance happens as well, maybe in the chair or in the top of the company if there's transparency. So there are many metrics that some companies might take into account, and this is something that are becoming increasingly relevant in the corporate world, not only to give a good image on the public, but also when it comes to loans, there is some banks that take into consideration the green aspects of a company. So this is something which is important to take into consideration. So knowing the impacts of these indicators can be beneficial in order to establish the factors the influencing this financial risk maybe of a company. So for our study, we will use an ESG perception index. We must to know that there is not a unique ESG score given, or just a solely standard of methodology of giving this score. But in this case, we're using this one, that it shows the aggregated trend of the ESG reputation of major companies, in this case, in Italian market. This is an aggregate indicator taking a company proximity to the 17 sustainability pillars defined by the United Nations Agenda on 2030. So this is the scores that we are taking for the analysis. Then going a little bit back to the literature review, these are some topics that were explained a few days ago by tutorial by Professor Guaracino. However, I will do some refresh of these techniques. When it comes to graph neural networks, we will use this for our procedure. But what is the graph attention network, which is one of those that we're going to use? In this case, the graph attention introducing a mechanism which is called attention mechanism to improve the aggregation layer in these graph neural networks. So it assigns an attention weight to each neighbor to weigh their importance during these aggregation steps. So we have an attention mechanism because these graph attention networks can focus on the most relevant neighbors for each node. And we can see here in the formula on the left term, the aggregated representation MNU of a node U is a weighted sum of its neighbors' features. And also, on the other hand, we have a multi-head attention, which using multiple attention heads, this helps to stabilize the learning process and allows the model to capture maybe different or more diverse aspects of the data itself. So in this case, this is the kind of method that we are using in our analysis. Each K in this case has its own attention coefficient and weight matrix. So the outputs of all of the attention heads are concatenated and then passed through an activation function sigma. Then, besides the graph attention, we are also considering the graph SAGE, which comes from the graph sample and aggregate. It's kind of an acronym. And this is interesting because it has a constant construction, because it creates a fixed size neighborhood for each node, making the model, let's say, scalable to larger graphs. And also we have this information aggregation that instead of learning node embeddings, this method learns aggregation functions. So as we see in the formula, this is the new aggregated embedding of the neighborhood of some node V as the first term after the aggregation of all the other features. Because the idea here is to update the embeddings of a node based on the feature of its neighbors. So after that, we have these aggregations, which combines the features vectors into a single vector. So this function actually can vary depending on the specific implementation. It could be mean, it could be LSTM, pooling. So there are different methods. We are using in this case the mean, which this means that the features of a node and neighbors are averaged to create the aggregated feature. Then the final step of the graph stage, in this case, is combining its own embedding with the aggregated embedding of the neighborhood made by the concatenation. Sigma, in this case, the activation function. We have used a ReLU, which introduces nonlinearity to the model. And the theta represents the weights of the model. So these parameters actually are learned during the training to optimize the embeddings. So to update embeddings, the update embeddings actually are used here to predict the graph context and labels. So from here, we can do several tasks. For example, we can do link prediction, graph classification, and also node classification, which is the one that we are doing. So our research approach in this case is use the node classification using these both GNN methods. And we take the perception index, the ESG scores, and we have categorized them into three different categories for the classification task. In addition, we have used other traditional classification methods such as KNN, random forest, decision trees, and A-based in order to make a comparison of these classification methods. Our dataset contains 180 Italian companies, which are those from the list from the major companies with the scores with the ESG from different sectors. So we have added also as well 20 financial and economic indicators, such as liquidity indicators, rotation structure indicators, and so on, because we want to put some information into the nodes as well, some features. So in our sample, the ESG perception rank is numeric, as I've mentioned before. It goes from 0 to 100, from lower to higher, and we have categorized them. And then decision makers, we're speaking about individuals, person with important positions on a high role, that participates maybe in the decision making and the government process of a company. So this is some aspect that we should also consider. What is a decision maker actually? So the network structure that we have is a giant component comprising 138 nodes. So there are 138 companies which are connected somehow in this giant component. And again, the nodes features are the financial economic indicators, and then we have the nodes labels, which are the categories of ESG, in this case labeled in a color code A, V, and C. So we have this distinction of the companies. Then if we speak about graph, we're also speaking about the connections. So the connections which are the edge are undirected, and this represents the shared decision makers. So in this case, we're not taking just no, we're not taking the frequency if there is one or two or three or four, but instead we're taking the weight of the Shakar index, which the Shakar index is often used to measure the similarity between two nodes based on their shared neighbors. So in this case, we're talking this Shakar index to have a different weight for the edges. It's not the same, maybe two companies with five decision makers and they share three. So they're very correlated that a company with other, they have 100 and 100, and maybe they share four. Even though they have a higher frequency, maybe they don't share the same amount in this similarity, let's say, weight with the Shakar index. So first of all, after creating the network, we have looked into the degree centrality and we have compared by ESG category. So in this case, the box plot represented the degree centrality in the y-axis and in the horizontal ESG category. This suggests that companies with better ESG ratings are more central in the network actually. This could indicate the great number of connections or influences. So this finding is supported with the Taki test, which shows you the pairwise comparison, so each class, which is class, of the mean degree centrality values between the different categories of the ESG. So the confidence intervals for the different means are displayed for each pair, and we can see that if the interval does not include that zero, it means that there is a significant difference in the means of this in the degree centrality. So there is a significant difference observed in A and C, the highest and the lowest. There is a significant difference in A and B, but there is not a huge significance difference between the B and C. Is in this case less pronounced with a 95% of confidence interval. Then we have taken this information. We have do some validation trend and splits. We have performed 10 independent runs and aggregate the results to do the classification. In this case, we can see that both graph neural network methods, this is to say the graph attention and graph stage, were outperforming the traditional methods with the accuracy. And also we can take into consideration maybe the balance accuracy if we could consider that there are some classes which were unrepresented, but still in the balance accuracy and the F1 score, such our colleague explained this to us, still the graph attention and the graph stage were better in these metrics. So having taken a look in these preliminary results, we can take these results, mention that there is a higher classification accuracy using the graph neural networks, and you also show us balance accuracy and F1 score in higher values. This suggests that incorporating relational data, in this case, shared decision makers, improved the prediction of the ESG perception index. Something interesting that we can take into account here and set our future research is the analysis of using multimodal graph. which use different kind of weights and different type of nodes, because we have companies from different sectors. There are different kind of weights because decision makers, there are many types, so we can also include this information for our purpose. We can study the temporal dynamic graphs, so how it evolves among a period of time, and also knowledge graphs. And also something very important for this, because this is just like a research we started with this analysis, but we have to explore the optimization techniques for fine-tuning these hyperparameters, both in GAF and the graph sage, in order to improve this efficiency. I think this is my time. So I give you many thanks for the opportunity and for participating in this really interesting workshop. And thank you so much for your attention.
Thank you. Thank you.